Alright, today we're going to be talking about section 5.11, and it's going to be called scale, distances, or dimensions. Now this one's kind of different than stuff that we've been talking about, so pay attention, and I think it's kind of interesting. But we've been talking about a couple different things. First, we've been talking about ratios. And if you recall, ratios are numbers like this. When we say 2 to 3, or 2 to 3, or even 2 to 3. Those are all ways that we can see those ratios written. Then we can take the ratio and turn it into a proportion. And this is two ratios that are compared to each other and that are equal. So we can say 5 to 10 equals 1 to 2. And this would be a proportion because I know that both of these are equal and they both work. Then we went and we said we can also have a unit rate, if you remember those. For example, a unit rate that we see often is speed driving cars. I could say 55 miles per 1 hour is a unit rate. And the unit rate means one of them is equal to 1, has a 1 digit. So 55 miles an hour, this would actually be an MI to make it miles, and that would make it a unit rate. Today I'm going to add an additional one, and we're going to call this, and I'm going to make it in a different color because it's different. It is a unit scale. And we see these the most on maps because we can't make maps nearly as big as the thing that we are attempting to map, or the map would be as big as the entire United States. So instead, we scale it down or make it smaller. Let's take a simple example. Two people are doing some geocaching. CHING. Remember, that's where people hide stuff and then you have to go find it based on coordinates. And on the map, it says that their scale is every 2.5 centimeters is equal to 80 meters. And on their map, they're reading on their little GPS. It says that they have to go from here to here, and the distance is 5 centimeter travel. So the question is, what's the distance that they have to walk? Well, now, it might seem pretty clear that if 2.5 centimeters is 80 meters, I can see that 2.5 times 2 is 5 centimeters, so I could know that their distance would be 160 meters, which is 80 meters plus 80 meters. However, whenever we use scales like this, we're not always going to be able to see them so easily and clearly so that we can just do simple math to get it. I want to show you the harder way to do it using simple numbers so that as we get more and more complicated numbers, it will make sense. So here's how we're going to write it instead. I can say that this scale that we've got here, 2.5 centimeters equals 80 meters. I can write that as a ratio. And I can say 2.5 is to 80. And I can write this as a scale just like I've done. Now, I can turn this into a proportion, if you recall, by adding an equal sign, comparing it to another equal ratio. And I can say, well, if this is my scale factor, this is going to be my actual scale. And I can write, well, 2.5, we actually went 5, because on the top should be our centimeters, and on the top we're going to have our centimeters. But the question is, I don't know what goes on the bottom in this case. And it looks like this. Now, when I get a proportion like this, I can use the skill that we learned earlier, those cross multiplication, to solve it. Now, I know this one is easy, but it's easy to practice this way. So, I'm going to cross multiply to solve. which gives me 2.5x equals 80 times 5. Now this I can just use my typical algebra to solve. I know 80 times 5, if I ignore that 0, is 8 times 5, which is 40. And then if I put the 0 back, I've got 400. So now I have 2.5x. I can divide both sides by 2.5. Cancels out here, which gives me x equals, and I'm just going to use my calculator on this. I could, of course, multiply if I'd like, but let's see, I've got 400 over 2.5 is going to give me 160. And my answer, of course, would return back to its units, and it would give it to me in meters. So my answer would look like this. This way, of course, is more algebra and more work than this way, but as you'll see soon, it becomes pretty important. Okay, let's go on to an example. Example 1. Let me find my color. Reset my page. All right. Example 1. Now, in this case, we're going to be looking at a rectangular backyard. Rano is building a map. Maybe he's more like drawing. He's not really building like a map, like a model or something like that. That would be cool, though. And his backyard is 50 feet by 30 feet. And we can call this our length and our width. This should definitely remind us of earlier doing our areas. And he wants to build a map, and the scale that he wants to use for his map is 1/2 inch equals 5 feet. All right, so in this case, I'm going to start off by writing down my scale factor. And my scale looks like this. I'm always going to write it as scale to actual. That's how we see scales, and it's much easier if we just use the traditional style instead of trying to create something new. So I'm going to write this as a proportion for two things, for my length and for my width. Okay, so my scale factor is 1/2, and I like to work in decimals. It's much easier in this case. So I'm going to write it as 0.5 over 5. Make sense? Okay, so for my length here, I know that my scale is going to be 0.5 over 5, and I need to relate it to my length. And I have scale over actual. So in this case, my small side is on the top, which I don't know, which I'm going to be trying to find out. And I know the actual measurement, which is on the bottom. My length is 50. I can write it the same for my W. Now, for my width, my scale is going to be the same. I'm going to write 0.5 over 5 equals, I don't know the top again, because I don't know what my scaled factor is going to be. That's what I'm trying to figure out. And I need my actual size. And my actual width of the backyard is 30. Now, with both of these, now that I have my proportions set up, I can cross multiply and solve. Okay, this one's going to look like this. It's going to say 0.5 times 50 equals 5x. And this side is going to say 0.5 times 30 equals 5x. I'm going to simplify these first. 0.5 is just half of it, so I know that this is going to be 25 equals 5x, and this side is going to be 15 equals 5x, because half of 30 is just 15. Okay, now I need to get rid of these 5s, and I need to do it to both sides, because whenever I do it to one side, I have to do it to the other. Well, 25 by 5, I know that one. That's going to be 5 equals x, because these cancel out. 15 divided by 3 is 3 equals x, my 5s cancels out, and now I have my answers. Now, what unit should my answers be in? Because they always need to have a unit. Whatever my original scale was in. So the x direction, or my L, my length equals 5 inches, and the width equals 3 inches. And this is what I can box. And this is how I can solve these. So these are tricky and they have a lot of steps. It helps to try to visualize it and understand what's going on. Now I want you to continue going and do this example too. You'll find that the homework is very tricky in this one. It doesn't give you just the easy answer in the numbers. Many of them you have to actually figure out and see where they're building and how they go. Okay? Let's look at another one using a similar scale. Actually, I'm going to change it. We're going to look at draw the blueprints of a building. Example 2. Okay, blueprints of a building. Our scale here is 1 inch equals 10 feet. Recall that whenever there's those little dots like that, those little apostrophes, that does mean inches. I can write this like this just so I don't get confused. Equals 10 feet. But it's good to know what that means. And on the blueprint, the building is 10 inches by 14 inches. Now, this is not a tiny mouse building. It's an actual building, but we want to know how big it actually is. So, some of you might know that this is a very convenient scale to work in because I can just multiply by 10. But we're going to go through the steps just so that we can get comfortable with it so that later you'll be able to see it. I'm going to write out my scale first in my typical scale way, and I'm going to write it as scale to actual, which is going to be 1 inch. We might even be able to leave the units in there. To 10 feet. Okay? Now, let's call this our length, and let's call this our width. We're going to start with our length, and I know that my scale is 1 to 10, and I know that my length is 10 inches, because I know the scale measurement, so I can put it on the top. But I do not know the actual. In this case, I'll just use the variable L so I don't get confused. For my width, I have the same exact scale, so I'm going to use that again. And this time, I know that my width is 14 inches, which is what I'm going to put on top. And I don't know the actual W, so I'm going to put that inside. Now I can cross multiply, just like I did before. I'm not going to circle these forever, but for now, at least today, I will. So I have 10 times 10 equals 1 times L, and I have 10 times 14 equals 1 times W. Well, this looks like it's pretty easy to solve. 10 times 10 is 100, and 1 times L is L. That's easy. 10 times 14 is 140. 1 times W is W. I need to remember to put my units back in, though, and I ended up with feet. So this should be 100 feet, and this should be 140 feet, which will give me my answers. I hope that makes sense. I'm going to let's take a look at some of the homeworks to make sure that I don't make you do something I didn't explain. Nope, it looks good. One of the things that's going to happen, though, is sometimes these scales are going to be much trickier. So your algebra is going to be harder. So make sure to ask people around you if you're not sure, or to ask me or other adults in the room to figure it out. I'll do one more. If you want to watch me and go with me, you can. You don't have to, though, if you don't want. Okay, example 3. All right, we're going to look at a map on this one. we have the bunkhouse, we have the dining hall, and we have a craft center. And our little person here traveled from here to here and then from here to here. And our distances are 4 centimeters and 2.25 centimeters. And our scale is, what is our scale? 0.5 centimeters equals 14 meters. And the question is, how far is it total? All right, so I really want to know distance is what I'm going to be looking for in this question. And I'm going to start off just like I did before by writing down my scale. Scale to actual equals 0.5 to 14. All right, so now the total scale, I'm gonna turn it into a proportion. I'm going to write 0.5 to 14 equals my scale. So how far in scale distance did she walk? Well, from bunkhouse to craft center is what I'm really looking for. So I can just say 4 plus 2.25, and I know that's 6.25. And the total distance is what I'm not sure of. I'm going to write that X. Actually, what I should write is D, because I'm really looking for distance, and that'll help me not be confused. Now that I've set it up, it's easy. All I have to do is cross multiply and rewrite and solve. So I have 0.5D equals 6.25 times 14. Okay, I'm going to simplify this first. And to do that, I'm going to use my calculator. 6.25 times 14 is 87.5. And to get rid of this 0.5 on this side, I'm going to multiply both sides. Both sides by 2. I turned my parentheses into a 2 because I was really looking forward to multiplying by 2. And this is going to, 2 times 0.5 is just going to give me D equals, I can take my 87.5 times 2 equals 175. What unit am I in? I can look up and I can say, I am in meters. So the total distance that this map shows and that we traveled was 175 meters. Hope that makes sense, and good luck.